All right, so give me some rules. Give me some things you had to, some rules you had to follow to get this thing to work. Go for it.
You can only put 2 electrons in each orbital.
Yeah, so each s orbital can only hold 2, right? And then for the p orbitals, there were 3 suborbitals. Each of those held 2 at a maximum. So the p orbital held a maximum of how many? Each suborbital of the p shell, right? So the total amount that the p orbital could hold was how many? Not 2, not 8. It was 6, right? Because there was a px, py, and pz. And each one of those held 2. So overall, the p orbital could hold 6. Okay, what else? What are some other rules? Yeah, right. So we had to fill from the bottom up, right? You had to fill the one S shell first before you could add other shells. Right. Once that was full, then you could start adding a new shell. And so when we add electrons in here, we always start at the bottom and fill our way up to the top. Okay, very good. Any more rules that were in there? What was the weird rule with the p shells? The p orbitals.
For some reason we wouldn't put 2 in first.
Yeah, I couldn't put 2 in the px, right? I had to start filling up one at a time, and then I could double up, right? Kind of a weird rule there, but that's how it works in atoms, right? You have to fill up those p orbitals one at a time, then double up. Any other rules you noticed? What was up with the arrows? What do you think those arrows represent? Because each arrow represented an electron. What do you think the arrows represent? Yeah. Any energy? No, not energy. Okay, if you've taken physics before, then you know this property of electrons. Electrons have what's called spin, okay, or angular momentum. It's not totally correct to think of them as spinning, but it's helpful to think about it for now. You can think of an electron as a small little ball that is spinning, okay? And if it's spinning in the direction like I've shown here, I'm going to show you a little chemistry and physics rule. Take your right hand and hold it up. Hold your right hand up. Okay. What I want you to do is I want you to curl your fingers in the direction that that electron is spinning. Curl your fingers in the direction that it's spinning. So you see like this? Okay. Now look where your thumb's pointing. That is what we would call the direction of this spin. We call that one spin up. Okay. What if I had an electron? Oops. If I had an electron that was spinning the opposite direction, it would be spin down. See how that works? Spin down. Now, I'm going to blow your mind. You ready for this? You ready for this? If you are ever trying to put a screw into a wall or into something, and you want it to go in, then you have to screw it in the direction that your fingers would curl. And if you want it to come out, then you would twist it in the other direction, in the direction your fingers curl. Kind of cool, right? Yeah. It's called the right hand rule. So I use it every time because I always guess wrong. But if I go, okay, if I want it to go in, I got to go this way. And it works every time. That's how screws are threaded. So I thought it was kind of cool. Okay. The right hand rule is just kind of how electrons work and how we thread screws. What's stupid is when somebody threads a screw the wrong way. That's annoying. Okay, so let's take a few more notes on page 7. Okay, we're going to be over here in number 2 and 3, and then this box over here. Okay, so when we represent the configuration, the arrangement of electrons in an atom, we use this notation. It looks kind of like this. Okay, so we have a number with the orbital followed by this superscript, and I'm going to tell you what each one represents. You can kind of see them. So the first part of it is this number. The first number is the energy level. Okay, so we're writing this down, yes?
Yes.
Yes. The first number is the energy level. Energy level, the first number written. It tells you the electron's energy. Okay, 1, 2, 3, all the way up to how many? As far as we know, what's the maximum energy level? It is, but what number would that be? Not 8. How many rows of the periodic table are there? there are 7. So the max number would be 7, right? Because when you were at helium, you were at the 1s. And then when you dropped down, you went to 2 and 3 and 4 and so on. So 7 is this kind of maximum number here. Okay, the higher the number, that means the higher the energy. Okay, so our rule is we always want to fill the lower energy first. Okay, so we never want to start, with 3 or 4. We always start at 1. We start filling up the 1 level first, then we move up to 2 and 3 and so on until we have all the electrons we have to account for. Okay, after the energy level comes the letter here, and the letter represents the orbital. Okay, each energy level can have multiple orbitals. Okay, specifically, you can have 4 of them. Okay, the orbitals, literally speaking, represent the probability, right? The probable location of an electron. If you're an s orbital, in what shape are you? You remember what the s orbitals look like? The s orbitals are spherical. Okay, the s orbitals are spherical. The p orbitals are more of this lobe shape, and they can be oriented right along this x-axis or the z or the y. Okay, because it's 3D space. And then they get even more complicated as you drop down into what would be called the d orbital and the f orbital. We didn't have to deal with that because the biggest atom you had to build was argon, so we didn't have to worry about d or f orbitals. Okay, but those do exist. Okay, those do exist. Okay, I want you to write these down right here. Okay, there are really four orbitals you can fill up. Those are s, p, d, and f. S, P, D, and F, and they go in that order, right? S orbitals typically have less energy than p orbitals, so we fill up s first. P orbitals have less energy than d orbitals, so we fill up p first. And then D has less energy than F, so we fill up D before F. F would be the last energy orbital we would fill up. Okay, cool. So you may have noticed this pattern. Let's see if I can find where I put it. Right here, right? All of these elements, if we were to fill up their shells, we would find that the s orbital is the last one we fill up. So that's why these two rows are sometimes called the s block. Over here, if we're filling up any of these, then the p orbital would be the last element or the last orbital we fill up. And so these elements over here, that'd be groups 13 through 18, that's called the p block. And then in here, the transition metals, okay, the last shell we'd fill up is the D shell. So we call that the D block. And then down here, those two rows, those are the F block, because F orbital is the last one we fill up.
Okay.
Yeah.
Got something from my mouth.
Go for it. Go for it. Okay. And then finally, we have right here this little number that's written as a superscript. That is the number of electrons. Okay. That last number there is the number of electrons. It's written as a superscript after the letter, after the orbital. Okay, and we know that subshells can hold a specific number. Okay, how many electrons can the s orbital hold? What about p? 6. And 6. The p orbital can hold a maximum of 6. S a maximum of 2. You can probably look at it. Check out your periodic table. What do you think the maximum number of electrons the d orbital can hold is? The d orbital. What's the maximum number of electrons a d orbital can hold? Well, think about it, right? If I'm going across a row and I'm in the s orbital, then 1, 2, and I'm done, right? That's why there's 2 here. When I get over here to the p orbital, I got 1, 2, 3, 4, 5, 6, and then I'm full. So look at the d orbital. How many can it hold? It can hold 10. Okay. The d orbital can hold a maximum of 10 electrons. What about F? 14. 14. Okay. So now you have a little bit more insight as to why the periodic table looks the way it does. Okay. It's all based on how many electrons these orbitals can hold. So I want to try to write the electron configuration for a few elements. You have 3 examples for number 4, right? Everybody see number 4? I like that sweater. Everybody see number 4? Does everybody have number 4? I'm going to keep asking.
Everyone say yes.
What? Yeah.
Do you see number 4 on page 7?
I see it.
Okay, how many examples do you have? You have 3. So what I'm going to do is I'm going to give you a non-example, meaning, or sorry, not a non-example, that's a bad word. I'm going to do an example that's not there. Then I'm going to let you try to do those 3, or at least walk me through it. Okay? So if I'm trying to write the electron configuration for neon, find neon on the periodic table. What column is it in? 18, so it's a noble gas, right? Okay, I want to write down how the electrons are configured inside a neon atom. Okay, where am I going to start? What energy level? What level? Give me a number. Where do I always start? I always start with 1, right? You always fill from the bottom up. So I'm going to start at level 1. Okay, so how many I guess that's probably the first thing we got to do is how many electrons does neon have? It has 10. So I have to make sure my configuration has 10 electrons in it. Okay, so if I'm starting with level 1, what's the first orbital I have to fill up? S, right? S. Okay, so moving across the periodic table, how many electrons are going to be in this 1s orbital? 2, right? If you go from hydrogen to helium, there's 2. So 1s2. So I filled that one up. Okay, what comes next? 2, right? Because there is no 1p orbital, right? That doesn't exist. We go straight to 2. Okay, so I got 2. What orbital am I going to start filling up? S, right? S comes before P. Since I have a new energy level, I've got to start filling up S first. Okay, so how many? 2, right? 1, 2. Okay, so there's 2s2. Now what? Now I can go to the p orbital, right? I don't have to jump to 3 yet because there is a 2p orbital to fill up. So we got 2p. Okay, and then how many? Go across that second row, and how many electrons till you get to neon? 6. I got 6. Okay, so how many total do I have? I got 10, so I'm done. This is the electron configuration for neon. It's got 2 electrons in the 1s, 2 electrons in the 2s, and 6 electrons in the 2p. Not bad, right? All right. I want you to walk me through lithium. Walk me through lithium. What do I do first?
See how many electrons.
See how many electrons it's got. How many electrons does lithium have?
3.
It's got 3. So I got to make sure that in the end, my electron configuration has 3 electrons total. Okay, now what? Got to start at level 1. Always start at level 1. Okay? I'm at level 1. What do I do now? I got to start with the s orbital. Always start with the s orbital. Okay, cool. How many are in there?
2.
It's going to be 2, right? From hydrogen to helium, that's 2. Okay, now what?
6.
Now I got to go level 2, right? There is no 1p. I got to go down to level 2 now. 2s or 2p? Got to start with 2s. Okay, how many?
Just 1.
It's just 1, right? Because that's the first element in the first row is lithium. So there's just 1 electron there. Okay, do I have 3 total? I'm done. That's the electron configuration for lithium. Okay, everybody write that down. So it'd be 1s2, 2s1. Okay, there's lithium. Okay, let's try oxygen now. Oxygen. What are you going to do first?
1.
No. What's the first step? How many total electrons does oxygen have? 8. Okay, now what?
1s.
1s. How many?
2.
Gotta have 2, okay.
2s.
2s, 2,
2p.
2p. Now how many till you get to oxygen? 4, right? I go boron, carbon, nitrogen, oxygen, 4. Okay, do I have 8 total? Okay, that's it. Yeah,
Wait, so why is it
why isn't it what?
3P?
Sorry, one more time.
3P?
Why isn't it?
Why isn't it 3P? Because I'm still in the 2 level, right? I'm still on the second row of the periodic table. I'm not in the third row, that'd be 3P. I'm still in the second row. I can't move on to 3S until I filled up 2P. Okay? So 1s2, 2s2, 2p4, that would be the electron configuration of oxygen. Okay, last one I want you to do, okay, or at least walk me through, is sulfur. Find sulfur. How many total electrons?
16.
16. Okay. Tell me what to do. 1s2, 2s2, 2p6.
3s.
Can I go 3p or do I have to start with 3s?
Yes.
Got to do 3s first. Okay, so 3s,
2.
2,
3p.
3p4. Right? When you get to that section, right, you started aluminum, silicon, phosphorus, sulfur, 4 electrons in that 3p orbital. Yeah.
So once you go to the next row, do you do 3s and then 3d?
Yes, so you can probably see by now, right? That what if I got to argon, then this would be 3p6, right? Okay, now jump down to potassium. Jump down to potassium. Everybody see that?
Yes.
Okay, so potassium, I'd start with the 4s, right? I had 4s1, then calcium be 4s2. Then what if I went one more to SC? What is that? What element is that? I don't know.
Scandium.
Scandium. Okay, what would I be filling up after that 4s2? It'd be the 3d, right? Not 4d, because I haven't filled up 3d yet. Okay, so this is where it gets a little dicey, okay? Because it turns out that the 4s orbital actually is lower in energy than the 3d orbital. That's why it gets filled up first. Okay. So if I picked an element like, I'm going to pick iron, for example, find iron. Okay, so for iron, I would fill up 4s2 and then I'd go 3d, how many? 6. 6, yep. Okay, be 3d6. If I were to fill up that whole shell, that'd be zinc, right? I'd have 3d10. And then if I went next to gallium, what would happen in gallium? What orbital would I start filling up with at gallium? 4p, right? So I was at 4s, I had to go to 3d, and then I go back to 4p.
Can you do the whole thing every single time, like starting from the bottom, or can you just start at 4s?
So there is a short notation. I haven't decided if you're going to need to use it because I don't think we're going to be filling up that many big atoms. But the short notation, kind of the shortcut, is what you do is you find the biggest noble gas, the biggest element from group 18, that's smaller than the element you're filling up. So for example, if I'm filling up aluminum, find aluminum. Everybody find aluminum?
Yes.
Okay, what is the biggest noble gas, the biggest group 18 element smaller than aluminum? It'd be neon, right? So typically what chemists will do is instead of putting all the electron configuration up to neon, they'll just do this. They'll put that, and then they'll start filling in after neon. Okay, so then I'd put the little box around neon, and then I would start 3s2, 3p1. And that would be kind of the shorthand for aluminum. And it's a little bit of a shortcut, but it really starts helping out when you're filling up like big atoms like uranium. Okay, but that's how the shorthand works. Okay. I feel like you guys got the hang of this. You feel okay about this?
Yes.
Yeah. We've got like 5 minutes. Let's do. Oh yeah, here's the blocks. Okay. Let's just do a couple more examples. I think we'll call it a day. We'll do a few more examples until the bell rings. Do you have any blank spots in your periodic table, or sorry, in your study guide, where you can just kind of write stuff down, or do you want to just talk to your tables about it? All right, let's talk. Okay, do beryllium. Get your just on that periodic table out. Talk to your tables, do beryllium.
Yeah, I think that's it.
Okay, everybody. 1 S 2. Okay. 4 electrons, we're good. Okay, what about sodium? Talk to your tables first. All right, we ready for sodium? All right, I'm gonna assume we're ready. Here we go. Tell me what to do. 1 S 2 2 S 2 2 P 6 3 S 1. 1 2 3 4 10 11, and I got 11 here, so I'm good. Okay, we did oxygen already. Nitrogen. Nitrogen. Okay, let's make a nice little choir out of this, right? In unison, step by step. Everybody. 1 S 2 S 2 2 3 1 2 3 4 5 6 7, and I got 7 over here, so that's good. We're getting better. We kind of trail off here at the end. What about chlorine? Find chlorine. This is a little longer. We're gonna get there though. Find chlorine.
Bam.
This will be our last one. If we do it good, it's the last one. If it's good, I need to hear everybody's voice. Okay, here we go. 1 S 2 2 S 2 2 P 6 3 S 2 3 P 5 1 2 3 4 plus 6 is 10 plus 2 is 12 plus 5 is 17. Yeah, looks good. So in shorthand, right, if I were to kind of take the shortcut, then all of this would be condensed, and I'd write Ne. So that's kind of the shortcut way to do it. Okay, nice job. We sound like a weird cult, a weird chemistry cult. Okay, good job though. There's some practice problems. I think we'll kind of work on some of those tomorrow, and then we'll kind of take it easy. I don't want to go crazy tomorrow.